Ever wondered what makes a wave a wave? It's all about how far individual particles are pushed and pulled from their resting spots. Imagine a string vibrating. Each tiny piece of that string moves up and down, or side to side, from its neutral, still position. This maximum distance a particle travels from its equilibrium position is called the amplitude of the progressive wave. Think of it like the height of the wave. From the middle point to its highest crest or lowest trough, a wave with a larger amplitude means the particles are being displaced further from their resting positions. Why is this simple measurement so important? Amplitude is directly linked to the energy the wave carries. A wave with a greater amplitude possesses more energy. This means if you're talking about sound waves, a louder sound has a larger amplitude. For light waves, a brighter light has a larger amplitude. It's a fundamental aspect that tells us about the wave's intensity. Measuring amplitude provides crucial insights into how a wave behaves. It helps us understand how much power is being transported and how the wave interacts with its environment. So, remember, the amplitude of a progressive wave is that peak displacement. The furthest a particle goes from its calm state. It's the key to unlocking how much energy a wave packs and revealing its unique characteristics.